So let us consider a question 0 to 3 modulus of x minus 2. It's definite integral within the limit 0 to 3, and here we have mod of x minus 2. Now this symbol is for modulus function. This is not an ordinary symbol. You need to acknowledge this symbol. Now if we elaborate the function, what exactly this modulus function stands for, we have modulus of x gives us answer x if x is greater than or equal to 0. That means if the thing placed here is already greater than or equal to 0, we get the same x as our answer. But on the other hand, we get negative of x as our answer under what condition? When x is less than 0. That means if this x itself is negative, then this modulus function will convert this x to a positive quantity by multiplying it by yet another negative sign. Here you can observe x itself is less than 0. When we say x itself is less than 0, what can be said about minus x? If I multiply by minus, we get minus x is greater than 0. So when we multiply by a minus sign in an inequality, then sign of inequality gets reversed. So you can observe minus x is positive. X itself is negative and minus x is positive. So what is the basic idea? Basic idea is if this x is positive for a portion or for a fragment of the interval, so we write the same x outside, but in case this x is negative, you attach this x by another negative sign and it becomes positive. So keeping in view, we have to work on this integral. Now anything which converts from negative to positive or from positive to negative definitely passes or becomes 0 in between somewhere. So that is the basic idea. You can observe this is being discussed for greater than equal to 0 and less than 0. That means it is about this expression written over here, which is very, very simple. In this case, it is x. Now, in place of x, whatever is written over here, we have to take it greater than equal to 0 first time and less than 0 the second time. We are considering equality sign in the first inequality here and strictly less than 0 in the second one. So while dealing with the modulus sums, remember that the expression inside the modulus must be equated to 0 every time. So here we have x minus 2, I equate it to 0. From there we get x equals to 2. Now by equating this expression to 0, I get a point, which is the point where we can say the nature of x minus 2 changes from positive to negative or negative to positive until this point is one of the extreme points of this interval. Now as we can see, this 2 is well within 0 and 3. So if I say 0 over here, 3 over here, we have 2 in between. Now using the property of definite integral, that when we have a to b fx dx and c lies between a and b non-alphabetically, then we can always split this integral into two parts. We can write a to c and then from c to b. Let me elaborate this thing also. If c lies between a and b, then a to b fx dx can be written as a to c fx dx, and then again starting from the same c where we ended, so c to b fx dx. Now this time 2 is in between 0 and 3, we follow the same rule. So this integral, it will become 0 to 2 mod of x minus 2 dx, and then from 2 to 3 mod of x minus 2 dx. This is the basic idea. This is how we can split this integral into two parts. Now after that, the main thing we need to do is to judge x minus 2 for its positive or the negative nature over this interval. We have to find what's the nature of x minus 2 between 0 and 2. So you pick any point of your choice between 0 and 2, say 1. feed it here. 1 minus 2 makes it minus 1, which is negative. That means this x minus 2 will assume negative signs over this interval. So, as we have done as per the modulus function definition, whenever the thing placed here itself is negative, when we remove the mod sign for that, we need to attach a negative sign with that thing. So the same is to be followed here also. The limits of integration 0 to 2, x minus 2 between 0 and 2 is negative. So when we remove mod, attach a negative sign with x minus 2, that converts it to minus x and plus 2. So this way we have talked about the modulus function over the first interval. Likewise, for the next interval between 2 and 3, we again pick any value of our choice between 2 and 3. Like we can take 2.5. 2.5 minus 2 is 0.5, which is positive. So just remove the modulus sign because x minus 2 itself is positive. It's already positive. So we have 2 to 3 x minus 2 dx this way. So this is the basic idea that is to be kept in mind while dealing with the modulus function. Rest you can do on your own, just like if we can integrate the first function like we have, say, minus here, x as integration x squared by 2, 2x integration as 2x, between the limits 0 to 2, and between 2 and 3 we have x as integration x squared upon 2 and minus of 2x. This is between 2 and 3. Hereafter, we can feed the upper and the lower limits of integration. In place of x, if I feed 2, we get 2 square 4 divided by 2. That makes it 2 with a negative sign. And here also, if I place x as 2, we get 2 to the 4. So plus of 4. And lower limit when we feed it, so it will be 0. So it is just like minus 2 plus 4 minus of 0. It is for the first portion. And plus for the second portion, you can observe here, if I replace x by 3, we get 3 square 9 divided by 2. So it is 9 divided by 2 here, minus of 3 to the 6 here as the first portion. And from there, we have to subtract the value of same expression for x equal to 2, which is again 2 square 4 divided by 2 simply 2, and 2 to the 4. You can justify the constants to get the final answer. Like for this one, we have 4 minus 2. We can write 2 for it. This portion is justified. And we have 9 by 2 minus of 6. We can go for LCM here. So we have 9 minus of 12 divided by 2. So what we get from here is minus of 3 divided by 2. And 2 minus 4 is minus 2, attached with another negative sign makes it plus 2, and this 2 plus 2 makes it 4, 4 minus 3 upon 2, that makes it 8 minus 3 divided by 2, giving you 5 by 2 as your final answer. So the most important thing that we have learned about this question is that whenever we are dealing with the modulus sum, in case of definite integrals, the very first step to start with this, that means the initiating step, is to equate the expression inside the modulus sign to 0 and to get the values of x from there and take into consideration those values of x which lie in between the lower and the upper limits of integration. Split this interval between 0 and 3 into, say, 2 or more parts. In case you have more values of x lying between 0 and 3, in that case, you have to split it further into more subintervals. And after that, once you have broken it or decomposed it into 2 parts, it is now the time to judge the nature of this x minus 2 over these intervals. That can be done by picking a test point in between the extreme limits in each case. And in case you are getting a negative answer, so when we remove mod, don't forget to place a negative sign before x minus 2, that converts it to minus x plus of 2. Like x minus 2 between 2 and 3 was giving you a positive answer. So nothing to be done, simply remove the modulus sign. After that, integration is very, very simple. Here you have applied integration of x is x square upon 2. 2 has integration twice x. X square upon 2 twice x. Upper limit minus lower limit. Simplify and justify and get your final answer. So in this case, we get 5 by 2 as our final answer. So over to the fifth question of this sequence.